You probably think a computer chip is just a tiny piece of metal inside your phone, but that's one of the biggest misconceptions ever. That tiny black square is actually one of the most advanced objects humanity has ever created. In fact, many engineers consider it more complex than a rocket engine or even a space shuttle. Now imagine this. If you could enlarge a modern computer chip until it was the size of New York City, you wouldn't see empty space. You'd discover an unimaginably dense metropolis containing tens of billions of microscopic transistors connected by an endless network of ultra-thin pathways. Every single one of those transistors acts like an incredibly tiny electrical switch, turning on and off at breathtaking speed. Together, they perform trillions of operations every second, and somehow, all of that fits inside something smaller than your fingernail. But here's what makes it even crazier. The people building these chips can't actually see the structures they're creating. The smallest features inside today's most advanced processors measure only 2 nanometers across. To put that into perspective, a single human hair is roughly 70,000 nanometers thick. That means these circuits are about 35,000 times thinner than a strand of hair. They're so small that ordinary visible light simply cannot be used to manufacture them. Instead, engineers rely on an extraordinary technology called extreme ultraviolet lithography, or EUV. This machine is so advanced that many experts describe it as the most complicated machine humans have ever built. It uses incredibly powerful lasers to blast tiny droplets of molten tin over 50,000 times every second. The impact creates plasma hotter than the surface of the sun, producing an extremely rare form of light with a wavelength of only 13.5 nanometers. That light is then reflected, not through glass lenses, but through mirrors polished so perfectly that even the smallest defect would ruin the entire process. The precision is almost impossible to imagine. It's often compared to accurately hitting a single coin on Earth while aiming from the moon. And yet, that's exactly the level of accuracy required. But here's the biggest surprise of all. Every chip starts as sand. Yes, the same material you walk on at the beach. Sand contains silicon dioxide. After an incredibly complex purification process, engineers create silicon that is almost perfectly pure, around 99.999999999% purity. Even a few unwanted atoms can destroy an entire chip. The purified silicon is melted at temperatures above 1,400 degrees Celsius, slowly grown into massive single crystals weighing hundreds of kilograms, and sliced into perfectly smooth silicon wafers. These mirror-like wafers become the foundation for every processor on Earth. From there, the real magic begins. Layer after layer, engineers build microscopic circuits using hundreds of chemical, optical, and atomic-level manufacturing processes. A single advanced processor may require over 1,000 separate manufacturing steps. Each wafer repeatedly enters clean rooms that are cleaner than hospital operating rooms. In fact, the air inside a chip factory is so clean that a single dust particle could destroy millions of dollars worth of chips. Workers wear full-body protective suits, not to protect themselves from the chips, but to protect the chips from humans. Every transistor created during this process becomes a microscopic switch. When electricity flows, it represents a 1. When it stops, it becomes a 0. Those two simple numbers create everything digital. Every YouTube video, every TikTok, every text message, every photo, every video game, every artificial intelligence model, everything your computer has ever done ultimately comes from billions of tiny switches flipping between ones and zeros. Modern smartphone processors contain tens of billions of transistors. Every second, they execute trillions of calculations, making decisions faster than the entire human population could count in a lifetime. And despite all this incredible progress, the semiconductor industry is approaching its greatest challenge. For over 50 years, engineers followed Moore's law, which predicted that the number of transistors on a chip would double roughly every 2 years, while costs remained similar. Remarkably, that prediction stayed accurate for decades. Computers became smaller, faster, cheaper, and more powerful every single generation. But physics is finally fighting back. As transistors approach atomic dimensions, strange quantum effects begin to appear. Electrons can tunnel through barriers they shouldn't be able to cross. At this scale, reality itself starts behaving differently. That's why companies are racing toward entirely new technologies, including 3D chip stacking, new semiconductor materials, optical computing, and even quantum computers. The next breakthrough won't simply make phones faster. It could completely redefine artificial intelligence, robotics, medicine, space exploration, military technology, and the future of civilization itself. That's also why computer chips are no longer just electronic components. They've become one of the most valuable strategic resources on Earth. Without them, cars stop being built, factories shut down, military systems slow down, artificial intelligence stalls, entire economies can suffer. In 2021, the global chip shortage caused losses of hundreds of billions of dollars, proving just how dependent modern civilization has become on something almost invisible. So the next time you hold your smartphone, remember this: you're holding billions of microscopic switches, carved from ordinary sand, engineered with atomic precision, performing trillions of calculations every second, inside one of the greatest inventions in human history. The real question isn't whether chips will change the future, it's who will control the technology that controls the world.